Alright, so I'm going to talk a little bit about identifying and evaluating functions and also finding the domain and range of a function throughout this video. And I'm going to start off with just how you identify a function. So I have here a relation, which all a relation is just a set of coordinates. And we're going to decide whether or not these are, or this one is a function or not. And the easy way to do that is just to look through and see if you have any repeated x values. And we do. We have a 3 here and a 3 here. Since the input value of 3 is getting two different output values, then we can say, no, this relationship is not a function. So here's another example of a relation. Again, we're going to just decide whether or not this is a function. And as you go through, you can see that we do have two of the same input values, but they go, they're mapped or they produce the same output value. So that's all fine. So since no x value repeats, that also gets mapped to a different number, then we can say that, in fact, yes, this is a function. And so now we can talk about what are the domain and range. So the domain is just the inputs, or in this case, the x values of our relation. So we don't have to put them in order, or at least I don't care if you put them in order or not. And you don't have to double count them if you don't want. So we're just looking at 6, 3, and 11 as our domain. And our range is our outputs, or our y values, and that's going to be -2, 7, and 1/2. So another way to view a function is graphically, and I just have a linear equation on there, just a straight line. And there's something called the vertical line test, and hopefully you've heard of that before. But it's a real quick way, if you have a graph, to figure out whether or not you're looking at a function. And all you're going to do is drag a vertical line all the way across your graph. And so I got to draw them here. But right, if we drag a vertical line all the way through this, you can tell that it's never going to hit this red line more than once at a time. And so therefore it passes the vertical line test, and you can in fact say, yes, this one is a function. Now we can also determine the domain and range from a graph. This is something I'm sure you know, but the arrows mean they go on forever and ever. And so when you're looking at a graph and determining the domain and range, you I feel like the easier way to do it is to try to figure out whether or not any numbers are not being hit. So, if we extend the line out in this direction forever and ever, eventually every positive y value and every positive x value will be hit. And likewise, if we go in the opposite direction, every negative y value and every negative x value will also be hit. And so the domain in this case is going to be all real numbers, and this is the symbol for all real numbers. You can write it out if you want, but since there's an infinite amount of them, you cannot list them out. The range, on the other hand, or likewise, is also going to be all real numbers. So here's another example of a function, or at least that we're going to see whether or not it is a function by using the vertical line test. So if you drag, check this out. I'll use my lightsaber. Right, if you drag a vertical line all the way through this, it's never going to hit more than one point at a time. So it passes the vertical line test. So yes, it is a function. And now let's look at the domain and range. So I think you can agree that if these arrows get extended out forever and ever, you'll eventually hit every x value, right? As this keeps climbing, every x value will be hit on the negative side and every x value on the positive side. So often, when you have a graph, you're going to have the statement of, yes, this is all real numbers. But look at the range. We have something a little bit different going on, right? This function never goes below this -2 value here. And so it keeps going up forever. So everything above -2 is part of your y values that are being hit. And so, but nothing below. So the easy way to write this is y is greater than or equal to -2, and that would be your range. And just to make the point about the vertical line test, this is not a function because you drag your vertical line and you see, all over the place, you're getting more than one place where it's crossing the red line. So this fails the vertical line test, and so this is not a function. So I'm going to start talking about evaluating functions, and I want you to always keep in mind that a function is just an input looking for an output. You get to control the input, or the problem, the situation controls the input, and then the function itself determines what the output is. So this part in green is actually a question. It's read, what is f of 2? But what you're really saying is, if I plug in 2 into my function, what value do I get back? And so this is a real basic one. It's just a linear function. And we're just going to plug in the value of 2 in for x. And then we're just going to evaluate it out. So we have two things going on here. We have two pieces of information. What we're saying is, if our input is 2, if our input is 2, our output must be 12. These come together. When you're talking about this function, f of x, the 2 comes together with the 12. They can't be really separated. We're not solving for this. We're just evaluating. We're just plugging in an input and getting an output. Now, they do come on coordinate plane. So you could say the answer is 2, 12. And both of these things are correct. So it doesn't really matter what is inside of the parentheses. You're just taking whatever it is and plugging it into the function any place you see an x, and then simplifying as far as possible. So here's 3 more examples of evaluating a function. And as long as you understand that it doesn't really make any difference what is in those parentheses, you're just going to take that and plug it in. Then evaluating a function is very simple. My wife called. Anyway, so this is just a placeholder. It's just wanting to be filled with something, and that something comes from whatever's inside the parentheses. So, don't look at it as it has to be an x. It can be anything. So for this first evaluation, it's going to be a -2. So, just like the other one we did. Oops. So we got 3 times -2 plus 6. And so that's a -6 plus 6. So again, when x is -2, when our input is -2, our output y is 0. But don't let these other ones throw you off. It doesn't matter what's inside the parentheses. So, when we're looking at this next one, f of z, instead of x being there, now we have a z. So our placeholder is going to be filled with the z instead. So this is really just 3z plus 6. So I should be able to give you anything in the world, and if I put it inside of these parentheses, then you should say, I'm going to put that in for my x value. So then in this case it's going to be 3 question mark plus 6. So here's the same function just represented by a graph. And don't look at graphs as some big mystery, okay? All they are is the visual representation of the rule. You know, it would take you forever and ever to plug in a bunch of values in here to get them out. So if you just want to kind of get a general feel of what's going on, then you take a look at it as a graph form. But you can use it to evaluate. So, you know, the x values here, here, are just your inputs. They're very boring. They're always the same. But once you plug them into the function, then you get to see what's going on. So, you know, I'm kind of off the screen here on the left, so let's just start at -4. When the value of -4 is plugged in, right, you get shot down here. The output would be -5. You know, and as you go along, these values just keep getting plugged in and shot into different places. Right here, they start going up. Right before this -2, they were all getting mapped down into the negatives, and now they're getting mapped all the way up after that. And this is because it's a linear thing, linear function. So if I can get rid of these lines here, let's evaluate it at the same spot as before. Oh, I misspoke my things off the graph. Right, this one, I apologize. Right, this -4 gets mapped down here. That's actually going by 2s. So then f of -4 is actually -6. Right? Right here, what's the output? Right, the x value, the input is -2. The output is 0. The y value there is 0. When the input is 0, the output is 6, right? So you can just go through and find your x values and shoot them up or down into the corresponding y values. Okay, so here's another example of a function that we can evaluate with a graph. So the first line here is the rule, and this is the visual representation of that rule. And we're going to find these 4 values by looking at the graph. Again, you could plug these in and get an answer. Okay, but if you have a look at the graph, you can also do that. So let's do this first one, right? When x is 0, right here, what is the y value? Well, I'm just going to track it down and see that the x value down here, where we found it, is at -6. So let's move to the next one. So again, you could take -1 and plug it in here, but let's do it through the graph. When x is -1, which is right here, go find the y value. Down here, remember we're going by 2s, so that's going to be -9. Or I got to remember we're going by 2s. Okay, let's go to the next one. When x is 2, again, you could plug it in, get an answer. But right, we can come over here, x is 2, follow it down, we see that it's also -6. And finally, we'll evaluate for 3, which is here. And we come down for another -9. Now this is only so useful because if I asked you to evaluate this function for like, well, something that's off the graph, you know, like 6 over here, right? You wouldn't be able to find it because the graph is too small. But also, if I asked you to evaluate it for maybe 0.5, you know, really, I mean, what is that coordinate? That's awful hard to say. So evaluating through a graph is only so helpful.